almost live. 10 seconds. Yeah, we are live now.
Yes, we are live.
Hello, everyone. Welcome to the third session of Online Space Workshop 2020. So today we have Mr. Félix Páez to talk on the title AMSAT EA PocketQube missions and designs. Hello, welcome, Felix.
Me, it's a pleasure to be here. I hope everybody enjoys this presentation.
So Mr. Felix is the president of AMSAT Spain, which is a non-profit ham radio association in Spain, like AMSAT Nepal. So educated as a computer engineer, Felix has been involved in 3 PocketQube satellites, which are Genesis, ESAT-2, and Hades, with the help of different universities and companies in Spain. So I'd like to welcome him and request him to start the presentation. Thank you.
Okay, thank you very much. Give me 1 second. I am preparing the presentation. I will begin in just 10 seconds. Thank you very much to AMSAT Nepal. It is a pleasure to be here. It's very nice to have some workshops in these times. We are everybody at home. Many of us can go outside and enjoy one of our hobbies is making contacts using satellites. So it is very nice to be here and are talking about our hobby and our projects from home. So thank you very much to AMSAT Nepal. Well, this presentation it's about the project AMSAT Spain, AMSAT EA is currently working. Small satellites for the radio amateur satellite service. I'm going to show you what are we working now with our partners, and well, I hope you enjoy. Index. I will talk a bit about who we are at AMSAT Spain, our current missions, and what are the goals of them, and we will have a look into the designs we are using. Still not all of them are finished. We're still working on some of the designs, but well, Genesis mission finished, so the design is closed. But we are still working on ESAT-2 and Hades. So well, we will have a look at the current designs and still we will see what we can improve in the next months. Okay. Who we are? Well, AMSAT EA, AMSAT Spain is an association. We are about 200 people on it. In it, well, the goal of the association is all related to amateur satellites. Many of our members just enjoy making contacts using amateur satellites or getting telemetry from them. Here we can see one of our members, Jose Eco Bravo 1 Alpha Oscar at Galicia, preparing for making a contact near the sea. But we also have an enduring part on the association. We are trying to build our first satellites. And well, we also have a web. We use Twitter to spreading all information about the amateur satellites. We are very proud of it. This is a hobby for us. This is not our work. We do all of this in our free time. So well, Sometimes it's a bit difficult to to build satellites all in free time, but that's why we have some help from universities and other organizations, as we will see now. Well, first of all, we would like to say thank you to Universidad Europea. Is our sponsor, and on ESAT2, this satellite is being possible thanks to them, to the students and teachers. Also, Universidad Pontificia de Comillas, another private university, they are working with us on the communication part. And the EAQRP club, another is a low potency, low power radio meteor club in Spain, and they are helping us a lot with the communication systems. For Genesis, we would like to say thank you very much to Everest, our sponsor on these twin satellites. Well, also to the students from Universidad Europea that are working with us on this satellite. Well, what are our goals? What are our current missions? Well, AMSAT EA is an association that has been inactive some years, but some years ago we began to think about building our satellites. We first began thinking about ESAT2, well, and we decided to try to make our designs, and well, to get the know-how to build a satellite, and sharing this effort with universities, with other organizations, even another AMSAT associations around the world. We would like to do all the engineering processes by ourselves, trying not to build just modules and connect them. We want to do the engineering, because for students and also for us, that's where the knowledge is, in designing and building the things, not just buy them and assembly them and put them in the space. That's also a great work, a big work, but we are more centered in the engineering part of the process. Another important thing is that we try to use discrete components where possible to avoid the radiation issues. This is a part of the engineering process, complicated, but we try to use it a premise on the process. Okay, so what are the current missions we are working now? First, Genesis mission. These are two twin satellites. They are already finished. They are here in Madrid, waiting for sending to Greece. There in Greece, they will join the satellites from Libre Space Foundation, and also the FOSA system ones. From then, they will fly to United States, to California, to the Vandenberg Air Base, where it is expected to fly using a Firefly rocket, the Alpha rocket. It is the first time this rocket is going to fly. So, well, they offered a free lunch to everybody, and we, with the FOSA and with the Libre Space together, applied for this opportunity. And well, Genesis, as I said, they are finished. We are just waiting to send them to Greece and from them to USA. And well, about ESAT and ARES, we are still working on them. These satellites are more complex. They are going to be in orbit more time. So we're spending a lot of time with them. Still a lot of engineering to do. We will be very grateful if anybody wants to join to this process, and we will have a look at their subsystem too. Okay, all our satellites at this moment share the same platform. This is because we really don't have time to work on different platforms at the same time. So we choose 1.5p platform. You can see it is a platform 7.5 centimeters. It's a bit bigger than 1p. We think this size is enough to do interesting things. We at first we thought about using a 2p for ESAT2, but we finally made it a little smaller, making it a bit cheaper. Still enough space for payloads. Well, we're pretty happy with it. The advantage of using PocketQubes, the main one is the price. They are cheap to send to space. Not like CubeSats. CubeSats are around 100 kilo euros. That's a lot of money. It's very difficult to small organizations to raise that money. PocketQube seems a good place to start. The main problem this platform has is low energy. You don't have a lot of energy with small panels, and there are a few launch opportunities. At this moment, only Alba Orbital is making launches each year, and this Firefly flight we are using this summer is an exception because LibreSpace developed a deployer, and well, maybe this deployer can be used in another rocket. We will see. So more launch opportunities will be available. Look at our Genesis mission. This is the patch, the 5 patch we made for it. These are the satellites. You can see they are pretty small. You can see their size compared to this small walkie-talkie. This small walkie-talkie a lot of people at AMSAT uses for making voice contact using amateur satellites. You can see the antennas. Antennas are long, especially the VHF band 1. Well, this is the prototypes at AMSAT headquarters. We are very proud of this work. And well, their mission is allowing us to have a first platform that we can evolve with the time. The satellites are same size. They only have a little difference on weight, as you can see. The orbit they are going to be is low. It's like 300 kilometers. So expected life will be only 3 weeks. 3 weeks, no less than 1 month in any case. And well, they are just ASK repeaters with Charlie Whiskey Morse beacon. The solar panels we use are not the space ones. They are very cheap. It doesn't have any sense to spend a lot of money on panels for a satellite. It is going to last less than 1 month. Well, we are using these satellites to test in space the reception part of the EASat-2 and ADES linear transponder. And well, you may be wondering why are we using ASK modulation. Well, we know it is not very common at this time in amateur radio, but we choose that modulation because it is very easy to process. When Genesis opportunity became available, we didn't have still the linear transponder finished. So we have to think about something very fast to develop. We choose ACE key because it is very simple to process. We will see that our onboard computer also work as a DCP. It processes the signal incoming from the receiver module. So we needed a very easy modulation to process. Apart from that, we have the applet ion system thruster, as you can see in the picture. It's a nice experiment, and we are very proud to have it on board. As I said, these are the milestones we have for Genesis. Very important to check all the systems on board, the EPAs, the onboard computer, and having a payload on board. It is very important. It is very nice to have this mission because ESA2 and others are going to last a lot of time in orbit. So it is nice to have this opportunity to test all works. This is a picture of our Genesis. You can see it in front with along with FOSA and with cubic satellites from space. This is in Barcelona. They were there for the vibration test, where they were qualified. All went really well. Well, now these satellites are ready to be launched. Okay, about ESAT and ADES mission. We know the ADES logo is a bit aggressive, but well, these are satellites made by young people. We wanted something different, something that you will look at and you will say, oh, that's really a different path mission for a satellite. Yes, I choose more conventional. Well, as a difference with Genesis, you see the solar panels are space ones. These are CubeSat panels in a PocketQube, so we have all the available area just for sun harvesting, so we can get all the power from the sun. But these panels are very expensive. As another difference will be, I will fire a camera, a slow scan TV camera. ESA2 payload is still not confirmed. Well, as I said, these satellites are going to be on a higher orbit, so they will last more than 1 year. The configuration we are working is R2, having that as a linear transponder or as a single FM channel. We will see that the linear transponder is complicated. We are not sure if it is going to be finished, but the FM channel part, yes. So that is probably the final configuration they will have. What is important for us in this mission is having the West transponder. Also, we have some capabilities of store and forward and packet repeater functionality. Well, we will see if all of this works as expected. We were sure that will be the case. A look at the designs we are implementing. You can see a picture of the Genesis prototype in some headquarters. This is Genesis with the antenna around it. It would be on inside the deployer for the alpha flight. About the structure, well, the structure is made directly of PCBs. We have some aluminum parts. They are just to have all together, so the screws can hold the PCBs, and the solar cells are directly over the PCBs. There in the picture, you can have a look at the inside of the satellite. In a cat, we will see images of picture of it here. Here you can see the look of these satellites, all the PCBs on one side, and a little space for the payload on the left. This is again at the AMSAT Spain headquarters. And well, about the solar panels, well, you can see the difference from Genesis to EASAT 2 and ADES. In the left, the cheap ones, each of these small cells are like €2. So all the panel just made the zoom is very cheap. And on the right side, we have the CubeSat panel that's very expensive, but it is made to survive space. A satellite that is going to last more that year, we want it to last. Here you can see another picture of the prototypes. In the left side, we see the only one side of the panels is left. Well, very small, but we are very proud of the design. Maybe we could have more space for solar panels, but well, it seems enough for this first mission. There at the right, you can see the battery we are using. It is the same as I using. And well, ESAT 2 was going to be a 2P first time, at first place. Here you can see the design we had, but as I said, we finally used the same 1.5P platform for our satellites, and this 2P idea was discarded. Well, about the power system, it is we will see this very common one. Here you can see how the power system is connected with all the systems on board. We have MPPTs, maximum power point trackers, to get all the available power from the solar panels. A small ion lithium-ion battery, a computer, an onboard computer that is having a look at everything and making all working as expected. Well, about the energy system, as I said, we first began to use LTC T129. These circuits are nice. A version of them fly on the $50 SAT. That's why we first choose these integrated circuits, but they are not really MPPT. So that's why we later changed our design, and we began to use the SPB 1040 that I think everybody is using now. On the right, you can see the harvesting energy part of the subsystem. Something interesting is that we don't have the battery directly connected to the energy bus. No. So the bus voltage is not the same as battery voltage. We have circuits that isolate the battery from the bus, and we can control how much current it comes from the solar panels to battery, and how much current we have from battery to the bus. Okay, this is a CPU task. Well, here you can see some pictures about our first test of the EPAs at Universidad Europea. At first we bought these modules. You can see on the left with the SPB electronics. It was a first a very fast way of beginning to test. And well, we made a small simulator, very rudimentary, but it was a first test, and it was very useful for us. Here there is a first prototype of the EPS with hand soldering and testing at our homes. Well, about the onboard computer, you can see a picture of the prototype. It was hand soldering this time, so we inspected it with a computer. It is based on a PIC microchip PIC. For Genesis, a very simple one. You can see the The RAM is only one 1 kilobyte. The flash program was almost full on this satellite, and for ADIS and ESA2 we choose another the highest version. It duplicates the available memory. The onboard computing makes a lot of tasks, as you can see here. As I said, it is also a DCP because it is sampling, having samples of the incoming signals to try to find telecommands there. So this 4 megahertz CPU is always busy doing something, not only reading sensors, watching the EPS to see if everything is fine, because if bus voltage would drop, the CPU would cut subsystems to make the bus stable. Apart from those tasks, as I said, it is sampling all the time, looking for command, looking for transmissions to repeat. And well, we implemented an ad hoc operating system, very basic, but it allows to have core tasks that are very important and are all the time running, and some scheduled ones that you can configure, like telemetry or the thruster payload activation, for example. And well, here you can see the antennas ground station at Madrid. Well, here you can see the Genesis design. It is very simple, just the reception part from the linear transponder we are designing, and some filters. All goes to the CPU logic. And as I said, we are using a MAX 7044 integrated circuit to generate the ESK telemetry and transmissions. It is very simple. We didn't have time for something more complex. On the app, you can see the transmission prototype. That's the MAX integrated circuit with these discrete components. About ADIS and ESA2, you can see this has become very very complex. Here we also have the STB camera. We have we will see on the right. We have a kind of voice synthesizer. It is the same integrated circuit logic that ET used in the film to call home. It is very nice. It is a very small program that can generate some phonemas, so you can say some words and transmit them. As you can see, all of this has become very complex. This part doesn't include the linear transponder, and that's something we are still working on. But we think the linear transponder is not going to be finished, but unless we have ESK, we have FSK, and we have FM voice. That's very important for us. Here you can see the first version of the linear transponder. This is what the first version. It has become very, very, very complex now. A lot of discrete components, a lot of work still to do. We will see if we could have it finished, but I don't think it is going to be possible. Well, about the antennas, you can see we are using measuring tip as everybody. It's a cheap solution. It works very well, but this will be only for Genesis. For ESA2 and other EDIS, we are going to use Nitinol. We are still working on it. We will see if we can have it finished. Here you can see some picture of the testing of the antennas at our headquarters at Madrid. Here looking at if all was correctly tuned between the transmitter and the antennas, using a small instrument for the measures. This is the parking at AMSAT EA headquarters as well. And well, about the communication, Genesis is going to have 4 types of packets. All telemetry, all of them is telemetry, except the the repeating transmission. Here you can see the telemetry packet types. The only difference is one of them is more frequent and another a bit less. They transmit different information, but all the information is generated at the same time. Here you can see the format of the telemetry. There's the call signs of the satellites. This telemetry may be not sent if there is enough power. The CPU would cut the transmission if not available. If not enough power is available. This is just an example of the packet type number 1. We will have all the telemetry formats on the website very soon. This is the more frequent telemetry. You can see it is transmitted the panel current, the battery voltage, the CPU voltage, the more common data we need. About the repeating capabilities of ADES and ESAT2, this is the provisional packet format we are working on. This is something more complex. It is still not closed. We have to think more about it. You can see we are not just using a protocol as AX25. We are making our own protocol. Of course, it will open for all radio amateurs. We will give the software. And well, about the thermal design, I can say much at this point because these are all analysis the students at the Universidad Europea made a pair of years ago. I think we have to do new models for the 1.5P. This is the 2P analysis, but it gives an idea of what's going on about the temperature inside the satellite. We don't have MLI for Genesis, but we will have for ADES and ESAT2. You can see a simulation of the inner temperature using MLI. Temperature seems pretty good, not very cold, not very hot. I think that solution would be very nice to have. One about the attitude control, we use a magnet, we use some hysteresis rods, as everybody does in small satellites, because there is no space for something more complex. You can see in the right how the satellite is going to be oriented with respect to Earth. Here you can see how we made some tests at the Universidad Europea about the attitude control system. And finally, our payload on Genesis, a nice work from Airplane Ion Systems. It's a smart thruster. It really doesn't have a great effect on orbit, like some meters on 1 month, but it is a nice experiment to have on board. Here you can see another pictures of it. As I said, we are very proud to have it on board, and we hope it works. So that's all from my side. Thank you very much. I'm ready for your questions.
Okay, thank you very much. It was a very awesome presentation. So yeah, we have a couple of questions. So I see that you have used a lot of discrete components. Like it seems a lot complex. So how difficult was it to troubleshoot all those components and test like the communication system of yours?
Using discrete components because we are worried about the radiation effects on integrated circuits. Okay, we need a CPU. We can do that with discrete components, but many other things it is possible to do with discrete components. These components are more tolerant to radiation. That's the reason we try to use it. But it is true that it is complex. You need electronics experts to do this design. So it is true that some parts has been difficult to design. We have lots of protection. This has been done with discrete components, and as you can see, the linear transponder part is fully made of discrete components. I can only say that it has been and it is being very difficult for us.
Okay. So another question is, in Genesis, you showed that you used a very cheap solar panels. So which solar panel was that, and what was its efficiency?
Well, in Genesis, these solar panels, as I said, are commercial ones. You can buy them in the electronics shops in internet. The efficiency is not very high. I think it's like 20%. They are made of silicon, but for this mission, we think they are enough. They are not going to live a lot. They are in orbit, so the price and the efficiency we think is pretty good.
Okay. So,
I have one more question. Yeah. So how are you going to test those thrusters?
Sorry, well, how are we going to use them?
How are you going to test the thrusters? Like, do you have any attitude determination system, or?
We made some tests of the thruster at AMSAT headquarters. The CPU sends a signal, and we know that the thruster has been activated. In orbit, in the telemetry, we will have a counter that everybody can see. Looking, it will say how many times the thruster has been activated. It has a maximum number of activation. I don't remember. I think maybe it was 1,000 times. The CPU will receive a command from Earth to activate the thrusters. And as I said, we will know it worked because we will see it in the telemetry.
Okay, and what about the power? I mean, the thruster seems to consume a lot of power. So how do you manage that system?
Okay, it is true that the thruster need a lot of power. In our first test at our laboratory, we have electromagnetic problems, and the CPU was reset. So we have to work a bit on the interface with the thruster. The thruster will only work using battery current because it needs a lot of power. That's true. So we only activating them when the battery is almost full.
Saurabh, your microphone is off.
Oh, sorry. So how did you get interested in PocketQubes? Why did you decide to build PocketQubes? Is it because of the price, or it's something else?
Well, price was the main reason, because at first we have a site of CubeSats, but when we knew the lot of money you needed to raise just to send it to space, we are not even talking about building them. We were a bit worried maybe we could not build a satellite. So when we saw there was a smaller platform, we saw the $50 sat. We thought that was very interesting. Also because it is a challenge. It is a challenge to work in something very, very small like PocketQube.
Okay, that's pretty good. So another question is, like, are all the PCBs you made are hand soldered? I mean, the FM PCBs, the flight models PCBs, are all those hand soldered, or you're planning to assemble it from the manufacturer itself?
Okay, in Genesis, all the PCBs has been hand soldered with a lot of care, as you could see. We used a computer camera to look at all the soldering. We tested it very well, and because we didn't have time, we did it by hand, but it is a very good work. For EASAT 2 and others, we will do or we will not do it hand soldering. We send everything to factory.
Okay.
So how do you like approach the sponsors, like, to support, to ask for the support? Like, how do you get the sponsors?
That's a very good question, because all of us that are working in non-profit associations and organizations, it's very difficult to raise the money for doing these things. Well, in our case, ESAT 2 is a project made with Universidad Europea. The students were looking for building a satellite or another interesting project, and it was something of a casualty. We could knew each other. So I think one main way of getting funds is talking with universities that are interested in beginning this kind of projects. About Genesis, we have the help from a company, Everest, that is supporting these projects. They also supported the FOSA 1 system satellite, and that's our main financial sources.
Okay, so and we also just registered our AMSAT Nepal recently. So what advice do you give, like how we can go ahead and how we can get started?
Well, we also began with a Almost There association. I think it is very important to use the social networks, like having a nice website, having an active Twitter account, and make all the noise possible. We began.
Yeah, we are trying.
Yeah, and also contacted other associations, so people know that you exist. But well, I'm sure you will succeed, because you are doing very well, and of course you have the help of AMSAT Spain to lend a hand.
Okay, so also, what softwares do you use to design the structures as well as the PCBs?
Well, we are using all this free software. For the PCBs, we are using KiCad. From the software, we use the microchip environment, and we try to use always the free programs, because if the people change, we can still work with these programs, because everybody can use a free program.
Yeah, we also always prefer the open source ones.
Okay, one more question. Like, since we are new here in Nepal, so there are not much amateur operators in Nepal. So how would you suggest our viewers here from Nepal to join amateur community?
Yeah, well, in Spain there are like 8,000 amateur radio people. But the satellite community was very small. I think maybe 10 or 20 people. But yeah, I think it is very important to have all the people together. Here in Spain, we also have a WhatsApp group in the association. It is not an official one, but many people is there. There are also some international WhatsApp groups and Telegram groups. Maybe trying to make a community using these tools is a good idea. But I think it's important the website, having a website that people know exists and can go there for looking for information. We decide to use Spanish for our webpage, because there are already very good satellites website in English, like the AMSAT UK one. So we decided to use Spanish. I think maybe in Nepal you should do the same, thinking about who is your audience and center in just in that.
So one more question, like, did you build Helmholtz coil by yourself for attitude determination and control test? So ADCS test, the coil for ADCS test, the Helmholtz coil?
Yes, this was a work made by the students at the Universidad Europea, and yes, I think they were made by them.
Oh, okay.
And also, how did you build the sun simulator? Like, what the designs?
Sorry, the simulator.
Yeah.
You mean the attitude control simulator? Sorry.
No, sun simulator.
Sun simulator.
Sorry, the sun. Well, you can see it is very simple. It's just a small engine that that is connected to a small wheel that just it moves the wheel very slow with a small bulb. I'm going to that. Yeah, you can see it's very rudimentary, but it is nice for our first test because you can see how the power goes from a solar panel to another one, and well, you can also maybe do this electronically or with more complex methods, but this is really simple, and for a first test, I think is enough, as you can see in the picture.
Okay, one more question. So what kind of connector did you use for the antenna port? Was it UFL or SMA in the satellite?
You can see the antenna is, I don't know where you can find a picture of the antenna. Well, you can see there, the antenna is just touching the screws on the PCB, and from there we have a wire. So it is directly connected.
So you are connecting the wire directly to the PCB, right? So you don't have any antenna port or antenna connector?
Yes, that's it.
Okay, fine. I think we don't have any more questions from participants.
And which is the battery that you are using that we can see in the photo? I think that's from Sony, right?
Yeah, it is a battery from Sony. Yeah. It is the same battery that's flying now on the FOSSA 1. Yeah. We tested it with FOSSA. It seems to be working fine. So we use it the same because it has flight heritage.
Okay. So in both the large and small, you use the same battery?
Yes, we are using the same battery. Just because of that, this battery has flight, so we know it works. Maybe there are better batteries, but it's complicated to find to choose one. This is small, has nice capacity, so I think we are going to use this one also for ESAT2 and ADES.
Okay.
I think we have come to an end, I guess.
Yeah.
Okay,
so is there anything that you'd like to add on?
Yeah, we'd like to collaborate you in future as well.
Well, I would like to say we are still looking for people to help us. We have a lot of tasks still open, and anybody that has any skill in electronics, programming, or thermal control, anything, just please contact us. We are very happy to involve more people, and of course other associations like AMSAT Nepal or from other countries. This is a joint effort. There is a lot of work, as you know, and with many people it is easy to do.
Okay, so we'd like to thank you very much for providing us your time. So it was a great presentation and we learned a lot. So we hope to collaborate with you and your organization in future as well. So we'd like to thank you very much. So
thank you very much.
Yeah, we are in the end.
Thank you very much.